All right. I just posted your first assignment in iCampus. You have about 2 weeks for this very easy assignment. Please read these 3 notes for grading. For ease of grading, your output needs to be deterministic. Without these requirements, some students print out this column not specified in the query requirement. So I listed some sample output table schema. So you need to exactly follow these output columns, and also you need to sort all the outputs in ascending order using the first column of the output table. Okay, and for average, if you look at this first query, you need to calculate the average salary of instructors in each department. Then you may use this division operator in the select clause. Then the column name can be changed by DBMS, and for grading purpose, I want you to rename that output column as follows here. So if you browse these queries, they are mostly very easy. So please do not use AI. If you use AI, you will get correct answers. But even if you do not use AI, these queries are very easy, so I believe most of you will get correct queries, even if you don't use AI tools. And so you need to write 10 select queries here, and then put all the 10 query statements in a single file named hw1.sql, and those 10 queries must be separated by semicolon. And then run this command, db submit, and this is the assignment code that you need to specify. For every assignment, this code will be changed. I haven't set up this submit script yet, so I will do the configuration after this class. So even if you finish homework today, please submit your homework from tomorrow. Okay, I will do the configuration by the end of midnight today. And you may submit the same file. You may submit this file multiple times, and only the last submission will be used for grading. And sometimes the students make some mistakes running this submit command. And just to verify your file has been correctly submitted, you may run this db check submission command. This is going to list what files are included. What files are submitted in the assignment. So you should check the file size of the file submitted, and if this file size is very different from what you have in your working directory, and you may want to submit db submit again. But a couple of bytes can be different. The size of the byte and size of the files can be slightly different, mainly due to this encoding decoding issues in the submission program. So if you are seeing small differences like 5 bytes smaller, 5 bytes larger, you may ignore those differences. And while doing this homework, you may have some questions, and I recommend you post those questions in our Piazza website. Any question about?
What's the version
You can use SWIN, EI, YEG, whatever machine you want. But you have to do this homework in our image cluster.
For the SQL file, we just need to put the query, not the output, right?
No output. Don't include the output. Just query statement. Okay. maybe later.
저희가 H1 먼저 SQL을 제출해서 이걸 어디다 저장해놔야 이게
In our image cluster, when you log in, you will be in your home directory. Inside the home directory, if you want, you can create subdirectories like named HW1 or database assignment 1 and go to that directory by running cd command. And then inside that directory, you can create a text file using some text editors like VI, Emacs, or Nano. And if you do not, if you're not very familiar with this Linux environment, then you may want to use VS Code. But VS Code is going to run in your local desktop or your laptop. Then you need to make a connection to our image cluster. I don't know how. I'm not very familiar with this VS Code, but if you're familiar with the VS Code, you should be. You should know how. So make the connection to this image cluster using your local VS Code editor, and write the SQL file and save it in our image cluster. Then the file will be created inside your working directory.
And if I open the PSQL at home directory and make an SQL file on that directory, then just enter the h1.sql and it will submit it. No need to directory.
Let me show you how. So run SSH command. You will need VPN to connect to this image cluster, and then create some subdirectory like db homework1 and go to db homework1, and this is your current working directory. And if you do not want to run VI or Emacs editor, then I may suggest a Nano editor. This is a very easy text editor. Here inside this editor, select star from instructor and put semicolon for every SQL statement. And then here it says that Control X will get you out of this editor. It asks whether I want to save this file, then press Y, and it asks me what file name I want to use for this file, and it's hw1.txt, press enter, and inside your working directory you will see hw1. Okay. How to submit? I just told you that you need to run db submit command. Let me show you. db submit hw1, hw1.txt. I told you, I haven't, let me do it. Give me 1 second. Let me change it. Oops. Sorry. Alright, give me 1 second. Oh, it seems already. Yeah, since I'm done now, let me go back. 1 second. Okay, as your student account, suppose Bnam is one of your student accounts, and db submit hw1, hw1.txt. got it. It's not going to take too much time. Let me do it now. No, not this one. Submit. I need to change this code. It is currently hard coded. All right. All right, I'm done. Now you guys can submit your project. See, now it works. So when you run this db submit command, you are going to see this output saying that your file has been saved in the instructor's account. And that submission script is going to compress your file, so the file size will be much smaller than the actual file in your working directory. The size of this file, actually it is larger. The size of this file is just 28 bytes, but the submitted file size is 149. So to check if your submission was correct, you may run this db check submission. Then it will show you that the compressed file currently contains this text file of size 28 bytes. And if you find any, if you want to submit your homework multiple times, you can do so. But only the last submission will be considered for grading. Okay.
Also, the dataset we use in this homework.
For the dataset, yeah, that is a great question. So let's go to sample database directory. Here I have a very small data set. This data, this file is going to insert just dozens of records into each table. So that database might not be big enough to check the correctness of your queries. So I suggest, where is it? Where is it? Strange. I believe give me a second. I think the homework should be it seems like the home directory is not shared by the 4 nodes. So in our image cluster, we have in server, G server, yes server, and E server. And all those 4 nodes, all these 4 nodes are supposed to share the same home directory, same disks. However, it seems their sharing is somehow broken. So I only see the updated files in SWG machine. I will update other machines as well, but I don't know what's the problem at the moment. But anyway, if you go to SWG machine, you will see a subdirectory named university data. Go there, then you can find a Python script. Oh no, there's no Python script. Oh, here in the parent directory, here we have a Python script. G server is so slow. Yeah, in the Python script, using these some how should I say, some I don't know. Using these some predefined and pre-written data set, it can generate any arbitrary number of records. So if you run this Python script, it is going to generate a bunch of CSV file. You can copy this script to your working directory and modify this Python script to increase or decrease the size of the data set. Anyway, so let's go there. Then you will see a bunch of CSV files, and when you load the Postgres.SQL file, this SQL file is going to read those CSV file and copy those data into your database scheme. Into your database. So you guys are familiar with the Python script, right? So you can manipulate, you can manage this Python script as you want, and then increase or decrease your database and verify your queries are working correctly. No. I believe I already explained all those things in the first class. So here we have DDL.SQL. Open this file, then you will see a bunch of create table statements. So your initial password is change this, and your ID is equal to your Linux account ID. And using your account, you will be able to access your database by running psql. And then, didn't I think you need to go back to the previous lecture recorded. It is available in iCampus, so you should watch it. Then you will know how to populate these data set. Okay? I don't want to repeat the same explanation again here. Any other question? No? Okay, then let's move on to our lecture. Where did we stop? Yeah. Oh, here. Okay. All right. So last time we learned we can call some aggregate function in select clause, and those aggregate functions are commonly used with the group by clause. So this group by clause should appear below from clause. So the logic is like this. So we access this given table, and if there is a natural join or some comma operators, then we perform Cartesian product and generate this large intermediate table. And from that large intermediate table, we sort records using the attribute specified in the group by clause. So in this example, we sort, or we may perform hashing to collect the records that have the same department name value. Anyway, so after grouping the records that have the same department name, we perform this aggregate function. That is how we use group by in SQL. And we learned this from a relational algebra lecture. Let's look at this. Here, department name is used in group by clause, and salary is included in this aggregate function. What about ID? When you have an attribute that is not used by aggregate function and that is not listed in group by clause, you will get syntax error. Okay? The logic of group by is to group records using this particular record specified in the group by clause, and then we need to perform aggregate function. But if we do not use aggregate function for this attribute ID in this example, then we do not know what to do with multiple attributes that belong to the same department name. Okay? We must use aggregate function for all the other attributes except those used in the group by clause. Okay, next. selection filter is specified in where clause, and additionally we may specify a filter using having clause, but this having clause will be applied after we perform group by operation, and where clause will be applied before we perform group by operation. So consider this example. We want to find the names and average salaries of all departments whose average salary is greater than 42,000. So here the filter condition requires average salary. This average salary can be calculated after we perform group by operation. Therefore, this predicate should be specified in having clause, not in where clause. If we have this condition in where clause, then we may get, it may work, but it will return different results from what we wanted. So here, we first access this instructor table, and we group records using department name. And for those records that have the same department name, we apply average function, and then we check this predicate. That average salary should be greater than 42,000, right? And if you use rename operator, then this renamed attribute name can be used in having clause. You can replace the average function with this new name. So predicates in having clause are applied after the formation of groups, whereas predicates in the where clause will be applied before we form groups. Next, what about null value? Suppose we have this table, and suppose we run aggregate function for salary column. The sum of salary will ignore null value. Average will also ignore the null value. Okay. There is one exception here. So aggregate functions, all aggregate functions ignore null value, but the only exception is a count function. This count function does not ignore null value, but when you run select count star from this table, then it's going to return 3. Next, nested subquery. This is the most difficult language feature in SQL. So you can call another query from a SQL query, and we call that inner query nested query. It is just like a nested for loop. So a query, SQL query, can call another query inside. And this subquery can be used in from clause, or it can be used in where clause. And let's talk about this in operator, not in operator later with some examples. So consider this. This is the simplest nested query. We want to find IDs of students who take a database class. There is another way of writing this query. We can use natural join operator. But maybe if you're familiar with high-level programming language like Python or C++, this might be more intuitive. So let's read this inner query first. In this inner query, we are accessing course table and check its title column, and we only select those records with database in title column, and we retrieve its course IDs. So here we have course table, and we scan this table and check if the title matches DB, the first record matches, and we select SW3003 from this inner query. Okay. So when we have such nested query, we first process inner query and store that intermediate output in main memory. So inside the main memory, this SW3003 will be stored as a table with a single record and single attribute. And then we go back to this outer query and access take table and scan these records, and we check the take table's course ID column. This should be course ID. So we check these values, and here the first record, we found this first course ID, and we check if this ID is included in the output of in query. So this in operator is like this, inclusion operator that we use in the set theory. So the right operand is a set, and left operand is a single element, and we check if this left element is included in the right operand set. Okay, so we need to check the first record of take table is included. And we check if the course ID of the first record of the take table is included in the output of this in query. It is included, then this in operator is going to return true. And since this whole predicate is true, the first record is selected, and we retrieve only student ID. I think this should be changed to ID. Okay, and then we move on to the next record and check if SW3004 is included in this output of the inner query. It is not, then in operator will return false. So we just move on to the next record and check if this is included in 3003 and so on. And the second to the last record also satisfies this in condition. So two records, 20 and 40, will be included in the output of this entire query. Okay? Are you following? Good. Okay, now let's find IDs of students who do not take DB class. This query can be written like this. Of course, there is a simple way of writing this query using natural join operator, but as a developer who are familiar with nested for loop those languages, then you may find this nested query is easier to write. So what we do here is we first access course table and check course ID of database course. So this record will be selected here. SW3003 will be selected. This is the output of this innermost query. And then we move on to the second level select query, and this time we access take table and check if its course ID is included in the output table of this innermost query. So this one and this one, these two records satisfy that inclusion condition. So 20 and 40 will be returned. So this middle query, second query is going to return a table with two records, student ID 20 and 40. Okay, and then now we move. We go to the top level and access the student table, and we check if the student ID is included or not included. If a student ID is not included in this second level output table, then this not in operator returns true. So let's check first record. Alice's ID is 20 and it is included. Therefore, this not in operator will return false. So Alice is not going to be selected. Then we move on to the next record. And 30 is not included in this output table. Therefore, 30 satisfies this predicate. So Charlie will be included in the output of this whole query, entire query. And what about Bob? 40 is included in this second level output table. So Bob is not going to be included. Only Charlie will be selected from this entire query. Okay? That is how we interpret this nested query. I believe this kind of interpretation is becoming more important in AI era. I mean, historically, we cared about the skills of writing SQL queries, complex SQL queries. If you can write complex queries in SQL, then people thought that you are a good programmer. But as AI is replacing these developers, I don't think that skill is that important. When you ask AI to generate some queries for you, AI may generate a very complicated query with lots of nested queries, and you need to understand what this AI did. So maybe maybe I plan to change my exam style. So I will give you complicated SQL queries like this. I mean, it can be more complicated than this, and ask you to interpret what this query is doing. That kind of skill will become more important, I guess. And next, find the total number of unique students who take, who is missing here, who take courses taught by the instructor with ID 10101. So if you look at teachers table, we have this course teaching information on instructor with ID 10111 taught SW 3003. Okay. After you identify the course ID, what you need to do is you should find the total number of students who took that course. So if you look at take table, it shows which student took SW 3003. It says student 20 and student with ID 40 took SW 3003. Okay, that is how we can interpret this query. And let's write this in SQL using nested query. First, you access teachers table and extract course ID, this one. And then you access take table and check each course ID column value is included in the output of this nested query. Okay. Can we simplify this query just for practice? Can you eliminate nested query from this? By using what? Cartesian product? There's a better way. Natural join? Yeah. We can use natural join. Just apply natural join first. We need to rename the operator. This ID is for instructor. Okay. It seems since the ID columns share the same names, maybe Cartesian product should be used. I don't think if you use natural join, then since both columns have the same names, we are not going to get the correct result. We are going to get 0 records in the output table. So yeah, Cartesian product is the right answer. So from take, comma, teaches, where takes that ID, course ID equals teaches that course ID, and teaches that ID should be equal to 10101. Okay, and then we need to select distinct student ID, which is the ID column of text table. Don't forget to put semicolon at the end. Okay, so this right query and left query, they will return the same output. So just like a relational algebra, the same query can be expressed in different ways. There are many equivalent queries, equivalent relational algebra expressions. Next, where is this? Let's read. Find names of instructors with salary greater than that of some instructor in the biology department. We have a salary column only in instructor table. And we should compare this value with the rest of the values, and we should compare this second value with the rest of 3 values. So we should compare this instructor's salary against itself. In that case, you can have the same table multiple times in from clause. And to avoid confusion, it is recommended to rename each instance of the tables. So here, do I have an animation? No. So after we rename these 2 tables into T and S, we perform Cartesian product, then we will get this large table. For the first record, Alice, suppose we have this is the table T, and let's say there's another table S that has exactly the same records in the table. We will, this Cartesian product is going to work like a nested for loop. So the cursor will point to this first record of table T, and another cursor will iterate through the 4 records of table S. So total, we are going to get total 16 combinations. That is, some part of the table is shown on the right side. And then what we need to do is we should compare left table's salary against the right table's salary. And only if the left table's salary is greater than right table's salary, we can say that the left record is making more money than at least one instructor of the right table. Actually, right table, left table, they are the same tables, but we are using the same table for both sides. So here, 80,000, they are equal, so they will not satisfy this greater than condition. If you look at the second record, Alice is making more money than Charlie, so this greater than condition will be satisfied. Okay, so Alice is going to be selected. Alice is making more money than at least one instructor. Oh, I forgot the second filter condition. The second instructor, the right instructor should be from biology department. And if you look at this example, in the second record we have Charlie in biology department. Oh, luckily, both filter conditions, both predicates are true, so Alice will be selected. And as you can see, there can be another biology instructor who is making smaller than Alice. So Alice might be selected multiple times, and we don't want that to deduplicate, to eliminate duplicate records. We need this distinct operator. And I have animation here. Charlie is not making more money than Alice. Charlie is not making more than Charlie. Charlie is not making more than Bob. Okay, I guess I can move on. All right. Here we have another operator that can be used for nested query. Sometimes this type of operators are called quantifiers. You know, in set theory, we use this symbol. Some element satisfy blah 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 predicate condition, right? And also we use this reversed alphabet A symbol to indicate that all elements satisfy blah 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 condition. This greater than some, greater than all, or less than some, less than all, we have those operators, and they are the quantifiers that we use in set theory. Let's understand what this query does. Let's look at the inner query first, nested query first. We access instructor table. This is the instructor table, and we only consider biology instructors. So Alice, Bob, these two guys will be filtered out, and we select only salary column. So this inner query can be replaced by a set that contains two values, 2000 and 3000. Let's use table notation. Salary 2000, 7000. Okay, this is the output of this inner query. And then let's interpret this outer query. Again, we access the same instructor table. Instructor table and check the salary column. So let's check the first record, Alice. Alice's salary is 8,000. And we check if 8,000 is greater than some of the right set, some element of the right set. Since 8,000 is greater than 2,000, we don't need to look at, we don't need to compare with the second element of the set, since this already satisfies this greater than condition. So at least one element of the right set satisfies this greater than condition, the whole predicate becomes true. So Alice will be selected. Oh, we don't need it. The right query does not return name and department. Only 2000 and 7000 will be returned. And move on to the next record. Charlie is making 2000. We compare that value with this right set. And is 2000 greater than some element of this right set? No. The smallest number is 2000, and it is equal to Charlie's salary. So this greater than some doesn't satisfy this predicate, so Charlie is not going to be selected. What about Bob? 6,000 is greater than 2,000. Although it is smaller than 7,000, it is okay. At least some element satisfy this greater than condition. Bob will be selected. Okay. So sum, comparison operator sum, this combination, this pair of operators are equivalent to these quantifiers in set theory. There exists a tuple T in set R such that the tuple satisfies a given predicate condition. Okay? And this comparison operator can be less than, or equal to, greater than or equal to, not equal. Any comparison operator can be used along with some operator, some quantifier. Consider this example. Is 5 less than sum of this right set? Yes. Since we have a 6, this is true. What about next one? Is 5 less than sum of right set? No. No. None of these elements are greater than 5. So this is true. This is false. What about third one? It is true, since we have at least one element that is equal to left operand. What about right one? At least one element is different from 5, so this is true. Okay?
I have a question about the third one. Is it, if we use in its equivalent, right?
Oh, sorry? If we
So instead of equal to sum, we use in.
oh, that is a really great point. Thank you for asking that. So, equal to sum is equivalent to in operator.
I didn't see it because of it.
But you should be aware that not equal sum is not equivalent to not in operator. Why? Consider this. If you apply not in operator for this element and set, this is going to return false because 5 is included, right? But this not equal sum operator is going to return true because there's a 0, right? Yeah. Another quantifier we can use is this OR operator. So this query selects biology instructor's salary, 2,000 and 7,000, and we access instructor table and compare their salary against these two values using quantifier. So is 8,000 greater than or salary of the right set? Yes. So this is true. Alice will be selected. What about Charlie? 2,000 is not greater than all elements of the right set. So this is not true because we have a greater number, 7,000 on the right set. So Charlie is not going to be included. What about Bob? We have 6,000 here. Still, David salary is greater, so not equal. Sorry. So not all elements are smaller than Bob's salary. So this Bob is not going to be included. What about David? David is not making more than himself. So this all quantifier will not allow us to include David in the output table. So again, let's consider this case. So again, comparison all quantifier is equivalent to this all quantifier in set theory or tuple that exists in table R such that the tuple satisfies. All tuples in set R must satisfy this predicate condition. That's the meaning of this quantifier. Let's consider this first example. Is 5 less than all elements of the right set? No. So this is false. And what about second one? Is 5 less than 6 and 10? Yes. This is true. And 5 equal all? No. 4 is different. So this is going to return false. And 5 not equal all. 4 and 6. 4 and 6 both are different from 5, so this expression is going to return true. Okay, now let's check if this not equal all is equivalent to not in operator. They are equivalent, right? Only when this left operand is not included in the right set, not equal all and not in operator both will return true. Okay, so equal sum is equivalent to in operator, and not all operator is equivalent to not in operator. Is it clear? Good. Two more operators, exist and not exist. Sometimes inner query may return nothing. Suppose we have an inner query that selects everything from table A, but its predicate is impossible to achieve. I mean, this predicate always return false. Then this select statement is going to return nothing, empty set. Okay? So sometimes we may want to check if this inner operator and inner query returns empty set or not. In that case, we can use exist or not exist operator. Exist operator returns true when right operand set is not empty, and not exist operator returns the opposite. It returns true when the right operand is empty set. And exist and not exist, these two operators are unary operators, so it requires only right operand. It doesn't need left operand. Right. Now correlation variable. We have a verbose slide with two-man text. So let's read it. Maybe I will give you 30 seconds to read. So what is correlated subquery? It is a type of nested query that references a record of outer query. So consider this right example. We just load the exist operator. Let's ignore it for now. Just look at this nested query. Here we are selecting a constant literal, number 1, when given predicate is true. We are accessing this take table and renamed it as T. So T.id, we know what T.id is. We need to look at take table and access ID column. Oh, what about this right operand of the equal operator? What is S? S is not defined inside inner operator. I mean, S is not defined inside nested query. But if you look at this outer query, we have a table S. Okay? This is called correlated subquery. And I told you that when we have a nested query, DBMS evaluates. DBMS processes the inner query first and generate intermediate output table and use that table for the outer query. That is how it usually works. When we have such a correlated subquery, we cannot do that because we cannot evaluate this inner query without knowing what outer query is doing. Okay? So when we have this correlated query, we must process outer query and inner query together exactly in the same way of processing nested for loops. That's what this bullet is saying. We need to process correlated subquery for every single row, single record of the outer query. Give me 1 second. Do I have an example? No. So let me explain how we process this query. We need a student and take here. Let me copy these two tables. Because of this correlated query, we should start from the outer table first, student.s. So we read the first record of a student table, and then we process this inner query. We access the first record of a take, and then compare ID columns of S and T. Is 20 equal to 20? Yes. So this first record, Alice, Alice will, give me 1 second. This Alice is going to return at least one record in the output table. It may return multiple records. If you continue, then we process the second tuple, second record of this inner table T, and we find that another 20. So what we get from this selected query is 1 and 1. I don't know what should be the attribute name here. Anyway, for every tuple, for every take tuple, every take record that satisfies this condition, we insert number 1 in the output table. And then we check whether the table is empty or not. Currently, it is not empty. Therefore, this whole predicate returns true. And then we go back to this outer query and select name of that attribute. So Alice will be inserted into output table. And then so this works like outer for loop and inner for loop. We go back to the outer for loop and move the cursor. So now we point to the second record, Charlie. And then we go inside this inner for loop and scan these records of take table and compare their IDs. Is 20 equal to Charlie's ID? No. Is 20 equal to Charlie's ID? No. Is third record ID is equal to Charlie's ID? Yes. Yes. Then we create. Oops. Oh, I shouldn't have deleted it. So we are accessing the second record of student table, and we are scanning take table, and we create a new output table for this inner query. And since these two records satisfied this predicate, 1 is inserted. And we move on to the next record, but they differ. The next record also differs from Charlie's ID. So just one single record is inserted into an intermediate table, and then we check if the intermediate table is empty or not. It is not empty, therefore exists return true. So Charlie will be also inserted into the output table of the whole query. So this is the total output. Alice was inserted previously. Charlie is now just inserted. And then the cursor will be rolled back to the first record of the take table. And we will move back to, outer query and move the cursor. So now we access Bob in the outer table and scan take table again to find out that the last two records have the same ID with Bob's ID. So again, this select query is going to return non-empty table. So Bob will be also inserted. Okay, that is how we process nested queries when they have correlated variable. Okay, when we don't have a correlated variable, we process inner query only once and keep that output table in main memory. It doesn't have to be main memory. If the table is so large, then intermediate output can be flushed to disks. But anyway, we keep that output table somewhere in main memory or disks, and then we do not process the nested query repeatedly. We use the same table for every record of the outer table. That is how we usually process nested query. But when the nested query has a correlation variable, we need to process that query just like we have nested for loops in high-level programming language. Question?
When we use exist operator, it is okay to use another number in Salat, or it should be only one?
So exist operator doesn't care about the cardinality, the number of attributes of the given table. Even if it has 1 column or 10 column, it doesn't matter. As long as the right operand table is not empty, it returns true.
So in this case, its output is print as 1. So it's okay to put another number in Salat.
Yeah, it doesn't have to be number 1. It can be ID s.no. It can be t.id, or it can be correlation variable s.id, or it can be anything. Since this exist operator cares about the number of records in a given table, there's no reason to return a specific attribute value. That is why we put number 1 here.
So it's not important this output.
Mm-hmm. Distinct? Where do we have this? Here. Maybe let's suppose there's another student named Alice, and her ID is 50. And let's suppose she took some courses. In that case, Alice will be returned twice. Included twice in the output table. Maybe if you want to eliminate those duplicates, you put distinct keyword. It's not required. That's not the main point of this example. Question?
If the correlation variable can be used to other inner subcodes,
Correlation variable can be used anywhere. Except the out. So we can have a very deep levels, like let's say this is query 1. Query 1 is using nested query Q2. It is calling Q3. It is calling Q4. And this Q4, let's say Q4 is using a correlation variable S, And S can be defined here, here, here. It can be defined anywhere. And let's suppose Q2 is using another correlation variable T. T cannot be defined inside Q3 or Q4. T should be defined in the outer scope. Okay? Only when T is in outer scope, Q2 can use T. Any other question? If not, let me give me a second. Let's move on. Let's look at another correlation variable example. We have 3 queries. This is one nested query, and there is no correlation variable. In that case, DBMS will process this query first, and then keep the result in storage or main memory. Let's say Bio 101 is the course ID of biology department. Let's suppose there's another course, Bio 102. So this is the output table. Done. And what is this second query? We are accessing text table, and we compare s.id against the text table's ID. What is it? This. Got it. Yeah, this is the most difficult query from my lecture. So what is this doing? So to figure out what this correlation variable does, again, we should think of that nested for loop and iterate each record. So we access one record from student table, and we check the student ID and go inside this nested query, and we check if that student ID is equal to text table's ID. So what we are doing here is we are selecting the IDs of those courses taken by that particular student. Okay? Following? No? Let's say we have a student table S and text table T. Let's say student ID 1, 2, 3 exists in S, Alice, Bob, and Charlie. And inside the text table, let's say Alice took database course, and Alice took OS course, and Bob took I don't know, programming language course, and Bob took OS course, and Charlie took just one single database course. Let's assume this case. This example is about biology department. Let's assume that database is a biology course. And okay, so we start from one single record of a student table. DB belongs to biology. And we access this text table and compare student ID with IDs of text table, and only those matching records will be considered, and their course IDs will be returned. Okay, so for Alice, database course ID and OS course ID will be returned. Right? Right. We are not done yet. This upper query, this second query, will return the course ID of database course. We assume that database is biology course. Let's just change it to database course. So this is going to return the course ID for database. And suppose this correlated nested query returned database and OS courses course IDs. They are the courses taken by Alice. And what does this except operator do? It will deduct this set from the set returned from this second query. When you deduct DB and OS from DB, what do you get? Nothing. 0. Empty set. So for Alice, this except operator is going to return on empty set. And therefore, this not exist operator is going to return true. And Alice will be selected. Why was Alice selected here? Because she took database course. That's the logic. That's basic logic. You should note here, in this query, we want to select students who have taken all courses offered from the biology department. When we have all or every keyword in a query, you should think of this condition. You should think of this condition. Y is the course list that a particular student has taken. And X is the all courses offered by biology department. Only when this except operator returns empty set, we can say the student took all courses offered from biology department. That is why we use this except operator and not exist operator in this given query. I see some students are nodding, but I see a lot of, most students look very confused. But since we are running out of time, maybe we should stop here, and maybe next time I will prepare animated slides to explain this query. Okay, that will be helpful.